All right. Part two of Cadathon, we're going to mainly be focusing on this first part here of fully constraining sketches within OnShape. So, what that's going to look like, I accidentally deleted my fancy animation here, so I'm just going to skip it. We're going to go from this on the first, on the left side here, to this on the right side. So inside your sketches, you may have noticed you'll either have blue or black shapes. So the blue indicates that there are still those parameters that we can change, whether it's their distance from one thing or its like diameter, its size. There's still some things that we can define. On the sketch on the right, we can see that all the lines, all the circles, all of it's black, so it's fully defined and cannot be changed any further. And so that's our goal. So, to start, we're gonna go, let me switch tabs. So, in your guys' document, we'll go to the top-down configurable parent folder, and then we're gonna go to this intake folder. So you guys are going to see this work in progress intake with a bunch of red and these weird looking parts that are very similar to the sketches we saw before. So to see what these parts are, we can go to intake parts, and this is the same part studio that sketch was taken from. We have two extrudes here for the two different plates. Does everyone know where we are? I heard someone ask. All right, so we want this sketch to get fully defined. And so this is for our intake, which we had a gear train of 4 different gears. That's these 4 different circles right here. Right now, they don't have any dimensions defined and are all over the place. For our intake, we also had a motor mounted that we're going to need to do. But first off, we should start with these mounting holes up top. So does anyone have suggestions for how we can start on these top 4 circles up here? Josh. Okay.
Are you in the
So,
training document?
If you're in your document, we can hit this home button to go to all tabs. We can go to top-down configurable drive base is the parent folder. And then we go to intake and then intake parts. Are all of you here in this part studio? Okay, so from the home of this document, so we're going to start in this part studio. You guys will only probably have one of these parts. So starting here, we have the different folders. We have our CAD imports, our concepting folder, and our top-down configurable drive base. Does everyone see this? I'm explaining how to get to where we were. So we're going to go to the top-down folder, which is right here on the bottom. We're going to click on that to open it, and then we have a bunch of new tabs we can pick from. We're going to be working on the intake, so we're going to hit the intake folder, and then we're going to go to intake parts. Does everyone know how to get here now?
Yeah.
All right. So, and then what I did is I left-clicked twice in quick succession to open this sketch. And all of you should have this sketch in front of you. So,
Left-click twice in succession. You don't have to select the
you
sketch
just on the left here, I hovered over this sketch and I left-clicked it twice. And that opens it, or you can right-click it and hit edit to open it. So this sketch is in everyone's document. And I want to start with these 4 circles up top. This is how we're going to mount it to here. You guys don't need to follow my steps, but this is how we're going to mount it to here. There's these holes on the side of our aluminum frame, or these are aluminum frame with 1 inch. Each of these holes have 1 inch between the center, and each of these holes have a diameter of 0.196. So, with that, does anyone have any suggestions for what we can do to define this? Ashton?
You could click the dimension button and make all of the circles the correct size.
We could do that, and that's a good first step, but we can do that a little quicker, because if we do that, we're going to have a mess of numbers if we have to dimension each one individually. So it'll make it a little bit harder to understand the sketch when we look at it. So I like that idea. So what I'm going to do is I'm going to hit the dimension tool. So I hit D on my keyboard, or you can go up top here and find this arrow. And I'm going to click one of these circles, and I'm going to dimension it to 0.196 for the diameter of the hole that we're going to use to fasten it to that frame. And then a tool that we have within our studios here is called the equal tool. You can hit E as well, but it'll be up top. Mine shows it a little bit more expanded than most of yours. It might be in a drop down, but we can click on that, and then we can hold Shift and click each of these other 3 that are going to be the same diameter, and then we click the one that's already defined without holding Shift. And what that's going to do is make them all that 0.196 size. But we're not quite done yet. So right now we can see what's not defined. If I click on this bottom line here and I start moving my mouse, we can see it moves up and down. I hit this one right here, it can move side to side. So right now, these 4 holes aren't given a spot in space. So we need to dimension it to something else. So I'm going to give this next step away. What we want this to do, we want these holes centered on this plate. So the way I like to do this, not necessarily the right way to do it, is I use the point tool to create a point. You can also hit Shift S, and then I go to this line here, and I go to the midpoint of it. So you'll see this little square start to pop out with a line and a point on it right here. Once you have that, you know that you're on the midpoint, and if you hit left click, you're going to have a point that will always be fixed to the midpoint of the line, no matter how long the line is. And then what I'm going to do is I'm going to create the same midpoint, but for the top of the plate here. It didn't go through. Okay, so now we have our 2 points. And if it's centered, these midpoints should be directly vertical with each other. And OnShape has a tool for this. It's called the vertical tool. We can also hit V, and then we select the 2 things we want to be vertical from each other. So we select that point and our second point. Don't know what just happened. We hit those 2 points, and it should solve the sketch. It's creating a point for some reason.
Isn't CAD the best?
That's useful.
I think mine is being a little slow right now. There we go. So now we see that these lines are blacked out, meaning they can't be moved relative to their surroundings. But the points on them, we can see that those are still blue because those points can be moved. So next, we can define how far the center of each of these holes is from the top. And so what we're going to base this off of is going back to this. You guys don't have to follow me. We can click on this line, and then we click on this circle, and we see that if we go to measure details, we can see the center distance from that top of the frame to the center of that circle is 1/2 inch. So going back to my intake parts, I can then press the dimension tool. I can click the line that represents the center of these two circles. Then I can click the top of the plate. And I'm going to click off in a space so that I can start confirming this dimension. And I'm going to make that 1/2 inch. That's 0.4. But if you do make an error like this, you can double click it the same way we got into the sketch and hit 0.5. You can also say you wanted as a fraction, you didn't know what 1/2 of an inch was as a decimal. You could do 1 divided by 2 in here, and it'll show you that it's computing a function with that little f, and the function's 1 divided by 2. Is everyone here and understanding it? If you're not, ask questions.
Midpoint, so I have it selected as being a line.
Oh, no, you need to create a point.
I see.
The midpoint is a constraint. That's a good point. Okay, so a good point was brought to my attention. So up here, from this tool right here on to the right, I think that's a drop down for most of you. These are constraints. This is what we're trying to do to our document. We're trying to fully constrain it. And so these are different tools we can use to give it definition. Like this coincide tool says that those two exist in the same space, share the same location in a sketch. Concentric, they share the same center, parallel, tangent, horizontal, vertical. There's all these different tools. For the midpoint tool, it's automatically applying this constraint when we have the point close to the center, because it's like OnShape is trying to make a guess at what you're doing. It's guessing that you're trying to make a midpoint on this line, and so it gives you that little suggestion to say, hey, if you click here, I'm going to make this guess and confirm it, and say that's what you're going to do. So to create that midpoint, we have to make a point and then give it that constraint. We don't start with the constraint. Because on the left here, these are your objects that we can add. Like we can add a line, we can add a rectangle, we can add a circle, we can add an arc. We can add these different objects, and then we give them our different constraints. Was your question answered, Gabriel? Okay. Is everyone here and understanding it? Okay. So next, all 4 of these holes are going to contain bearings that we use with hex board, just meaning that a hex shaft is going to be able to go through it, right? And so this is just a measurement I have memorized, but if we didn't, we would be able to find, like, in here, you guys don't have it, but like, if I put a bearing in here, we're trying to put this in the plate, and we can find the diameter of this bearing by clicking this line, and then in the measure details down here, it says it's 1.124, so 1 inch and almost an eighth. And what we do, because our CNC cuts a little short, we put 1.125, and we're still going to have to sand it out a little bit anyways, because we want these to be press fit. So I'm going to dimension this first circle, 1.125, and then I'm going to use the equal tool, and I'm going to select these 3 others, and then hit the one that is dimensioned. And now all of these have that 1 1/8 measurement. Does everyone get this so far? 1.125 is the measurement we're going to use for these bearing holes. All right, are we good to move on to the next step? All right, so for our intake, the two bearing holes on the side here, these are going to have our 2-inch diameter rollers on them, right? And this 0.25 right here, that's saying that this plate is 1/4 of an inch off the ground. I think in reality it's a little bit more, but we're going to base everything off of that. So the first dimension, so the first thing we want to do when saying our rollers are this far from the ground, it's nice to have a representation of our rollers in here. So we can make a circle. We can hit C to make our center point circle, or we can go up here. But then we're also going to want to hit either Q or hit construction right here. This makes it viewed as like just a, it's kind of like a constraint. It's not going to be viewed while we're extruding it. So if we hit extrude on this plate, it won't be able to extrude that circle that we're about to make. So then I'm going to go and click on this circle, but I want to make sure that I see this coincide icon, the little sideways T, in the box next to it. I click on that, I just drag it out, and then while the box right here, while there's still that gray box around it, you're going to want to type 2 and then hit enter to make it a 2-inch diameter. If that gray box went away for you, you can also just use the dimension tool. And then we're going to do the exact same for this one, but we don't want to clutter the numbers, so I'm going to use the equal tool to set the 2 dimensions of these rollers equal to each other. You good, Kyle? Let me interpret this. I know why it's like this now. All right. We ready to make it so that these wheels are offset height-wise? All right, I'm going to give a little bit more time. I'm going to answer a question quick. You haven't added the second circle.
Yeah, but like this definitely didn't catch it.
All right.
Everyone good? See what's going on?
I'm gonna back up a few steps and just redo some work. So is everyone to the point where all 4 of these bearing holes are equal in size? Okay, so the next thing we're gonna do is we're gonna add a construction circle. So we're gonna go up to the top here, a center point circle, and we're gonna hit this to make it construction. So sketch new construction geometry or convert existing sketch entities into construction geometry. So then we're going to create a circle that has the same center as this circle. So we want it to have this coincide tool or this coincide icon. Let me get it to show up for you. We want it to have this when you click it. That little T. That says that the center of that circle is going to take up the same space as the center of the other circle. Then we're going to click to confirm that we want it there. We're going to click out. And while this measurement, that for me, it says 1.823, while it still has that gray box around it, that means we can still edit it by just typing in numbers. We don't need to hit enter. We don't need to click that box. We can just type 2 and then hit that because our rollers are 2 inches in diameter. if that box went away for you, you can just use the dimension tool. And then we can do the same on the other side. We can add another construction circle, use the equal tool this time to set the diameter of this circle equal to the diameter of that circle. Does everyone understand how to get to this point? Okay. Now that we're all here, we can start defining some things. So this 0.25 is actually from when we were first making our intake. We ended up shimmying it up from the frame. But with that 0.25, it doesn't matter right now. We're going to hit the dimension tool. We're going to hit this leftmost roller, and we're going to do the dimension from the circle to the origin. And then we don't want it to be sideways like this. Automatically snapping to that. So I'm going to grab a different point on the circle. I got it. We're going to do unq. I'm just going to make something on the floor here. Oh, wait. Dimension here to here. I'm going to make it negative 0.25. And that'll snap it to be the same.
Just because numbers change.
Yep.
You're probably better off using as many controls as possible. You're probably better off doing what we're doing, snap a construction line to there. Because now if you need to change that 0.25, you have to change it in 2 places. You have to remember you're changing in 2 places. So if you snap a construction line there, that may be...
That's a good point. Craig brings up a good point for like the flexibility of things. So I'm actually going to delete this 0.25, and you guys can do the same for those following along. So that's going to mess up a few of our constraints, but that's fine. And I'm going to create a construction line. I'm going to have it so it has the horizontal line showing that it's going to be horizontal. And then the distance from this plate to the ground in reality is 3/4 of an inch or 0.75. So what this did is it shifted our entire plate up. So then the distance from this to the ground here, that's going to be 0.25. All right, does everyone know how to get here?
1 second.
All right. Looking good. Yeah. All right, so we're going to leave that 0.25 dimension. So just click on it, hit delete. And then we're going to add a construction line. So we're going to hit the line tool. Yep, it doesn't matter what order you hit it. And we're going to hit the origin. Yep, it's the 0, 0 point. We want it to have that horizontal line up good, but just keep going up. It doesn't really matter. We want it to be horizontal. Parallel is going to do the same thing, but it's okay. I'll just hit off button. And then distance to the bottom of this plate to the bottom of that line to be 3/4 of an inch.
We'll also make not
Okay. I find the burden of the audience to be it's 0.75. So you need to hit left click to confirm it. Yep, and then 0.75.
Making sure that it's correct angle.
Have a good day. Yeah, I'll make a version of the document and you'll be able to make it a copy. So line Q to make a construction line.
Construct that one.
On the origin, and it's horizontal. It's a linear counting part. Parallel is going to be the same thing because that line's dimensions are constrained to be horizontal. So it's off the line. How's that he can help you?
Well, no, I just like I keep I'm doing this and then I'll do it and then
Right now, you're dragging up far. It's doing the distance on the other side. So drag it above the line. And then dimension it so it matches that. Yeah.
Double-sided HD.
we just have to project so it's gonna be useful.
That's because I also did. This is if we were working from like scratch.
You did the same thing I did.
Oh, that was
That's
that.
valuable skill.
Oh,
You have the belts run.
Way back when we had these on that.
Multiple different.
There is going to be valuable skill here in a second.
No, I really because I knew I paid attention to those classes. I didn't just
Are all of you good now? All right. So next, we're going to be dimensioning the top roller from the ground. And that will be 1.75, right? Right. No, something's up. Hold on. I know what's up. What?
Is it 2? I think it's 2.
No, I think all my distances are offset just a little bit here. So this should be 0.5, and then this is 2. So yeah, you're right. It is 2. Boom. So it'll be right over top of the note because our note is 2 inches tall. So we're just dimensioning the minimum distance between this circle and this bottom construction line is 2 inches. By just dimensioning between the circle and this bottom construction line, that's representing our floor. This 0.5, I changed a distance for those following along. So instead of 0.25 between the ground and our leftmost wheel, it's 0.5. So half an inch. All right. Are you ready to move on to the next thing? Okay. So the next thing is all 4 of these gears. This is a gear train. So we're going to have 4 gears that are working to spin these in opposite directions. Let me switch the meat 1 second. So to something else. Hold on, let me skip past this. All right, so we're going to use 4 gears because it's going to cause our intake wheels to spin in opposite directions, which will act to suck the note. But if we did like an odd number of gears here, they would be working in the same direction. So in our intake, it would just not work to suck up the note. So for our intake, if we're doing like a 2 roller design like this, we'll always be using an even number of gears. So for our gears, these are going to be ripped straight from what was actually on the robot. So we can go to, let me share the whole screen. we can go to West Coast Products Gear Calculator. So this is a good tool while we're CADing gear trains because one, it'll tell you like the center between gears, the ratio between them, that stuff. But right now, we don't really care too much about the center. What we care about is the different gears that we're using and how many teeth these have. So we have 3 different types of gears. One of them is repeated. So the first gear we have are 2 36 tooth gear. So if we go into this website, we hit enter, we can see it gives us 2 dimensions here, a pitch diameter and an outer diameter. So for what we're doing in CAD, pitch diameter is what we care about. That's the lower part of the gear. So that shows where the gears are interacting. So if we have 2 gears in CAD, we can represent those as just circles with their respective pitch diameters and have those circles touching. Sam. Outer diameter, that's for like how far the teeth stick out. So like in this 36 tooth gear, I think Craig's gonna do a good drawing.
Pitch is like where the circle of the gear starts.
Yeah. So the pitch is like the valley of the gear.
Okay.
No, it's not.
It's kind of almost halfway in between.
Yeah.
Okay, so you have two.
Well, yeah.
Three different dimensions here. Is the outer or major is here. This is the tip of the teeth. This is going to be your minor, or at the root of the teeth. Pitch is going to be right here, basically at 50%. The reason for that, when you have a mating, better marker. Okay. So when you have a mating tooth come in here, the reason we use pitch diameters is because that mating tooth also has that same pitch diameter to it, and this diameter is where they need to meet. So those 2 pitch diameters should be tangent to each other when you mate 2 gears to each other. That's why we use the pitch diameter, and we don't care so much about the major and minor diameter. We really care about that pitch diameter because that's how you determine how far apart those gears. Because you do not want these 2 areas touching at all, right? So you want to make sure that you have plenty of teeth engagement, but you also don't want to be bottoming those out. So that's why pitch diameter is used.
Thank
make
you
sense?
for that explanation.
Okay. Since we use gears a lot, I thought I'd go through that.
Yeah. Let me unpin.
So can you say how you got to the pitch to the gear calculator on West Coast Products? If you go to West Coast Products and search gear calculator, you don't get it. So how did you get it?
I just went to the search bar here and looked up West Coast Products Gear Calculator.
So you did it right from.
Yep. And I searched it up enough that it's the first result. It might not be the first result for you, but it shouldn't be too hard to find it. But once you click on that link, it'll just send you to this. So, and we're using 20 DP gears, and we're using inches. And so our first gear has 36 teeth, and the second gear that this interacts with has 42. So that's a pitch diameter of 1.8 and 2.1. So going back to our CAD document, so that first 1.8, that is on this circle right here, the rightmost. And what we're going to do for that one is we're going to have another construction circle that shares the same center. We're just going to click out of it, and that'll be 1.8 for the diameter. So it'll end up being the center circle between the 3. And then for the 42 tooth one, that's going to be this second one right here. So we can start another construction circle on the center of this circle, and that'll be 2.1 inches. And so, like he said, like Craig said, these two pitches, or these two circles, when we're representing them in CAD, have to be tangent to each other. And luckily for us, there's a tool for that in OnShape called tangent, or we can hit T on our keyboard. So then we just hit the two sketch entities that we want to be tangent, and it'll make it so that these two sketch entities are always tangent from each other. So is everyone here with these two tangent circles that are representing our gears?
And it's the smaller one of the two construction circles.
Yep. For the one that has a lot going on, it's the smaller of the two construction circles that has the 1.8. I accidentally typed 1.85, so I'm going to change that.
You showing the large circle as the outer diameter, or is that something else?
The larger circle, that represents our rollers, since we cared about how far they are from the ground. Sometimes we wouldn't need to represent these rollers, but for this specific case, we wanted to know how far they are from the ground. That's why we have them represented as construction circles.
Okay, yeah.
Yep. All right. Does anyone here need more time? You need more time? Okay. So then the next two gears that are interacting, from the 42, it's going to go into a 20 tooth and then a 36. So I'm just going to change this 40 to a 20. And so that has a pitch diameter of 1. And then we're also going to have 1.8 again. So from this circle,
Maybe just an important point for everybody, just so you can think about what this means. The reason that the 22 gear is a pitch diameter of 1 inch is because these are 20 BP gears. So all of the gears we're going to use, it's if there's 20 teeth around it, and it's 1 inch in diameter. And everything else is calculated from there. So if you want to go with a 40 tooth gear, it's 2 inches in diameter. 60 tooth gear is 3 inches in diameter. So you don't actually need a gear calculator if you can do simple math with either your calculator or your head, because we know it's 20 tooth per diameter. So 20 BP means diametral pitch 20 per inch. So sometimes it's called DPI, diametral pitch per inch. So, shortcut.
Yep. I
And
like
it's actually,
oh,
it's actually handy to type that in as the dimension, 42 divided by 20, because then it's recorded there. And if you hover over it, it tells you the DP of the gear and the number of teeth.
So yeah, we could represent this as 42 divided by 20, and that'll give us the same dimension. But I think, who said that on the meet?
This is Lee with Wildcard.
All right, as he said, as Lee said, we can represent it, since they're 20 DP gears, we can actually represent it as that fraction of the number of teeth over the diametral pitch of the gear. So that serves to give you more info if like someone else was going to go through this document and try and get some information from it. So just to keep this a little more simple for everyone else to follow along, I'm going to not do fractions, but it's probably best practice to do fractions so that it's easier to understand what's going on if anyone comes back to the document. But our 20 tooth gear has it'll have a pitch of 1 inch, and then we're going to use the tangent tool and make that tangent to our other gear here. I'm just going to move it out of the way. And then onto our next one. That'll have the 1.8 diameter, so 1.8, and then we can tangent these two circles. And this sketch now can fully represent a gear train that could go on a robot, and we could drive using this. But if you look, there's still a lot of dimensions here that are not defined. So we just want to make sure that our sketches are fully defined and that our dimensions actually have reason. So the next dimension is how far this outer roller is going to be from the wall here. So this 2-inch roller here, we want that a certain distance away from this wall. So we're just going to dimension it between these 2 points, and we're going to make that 0.375. And you can see that we already have one of these points fully locked in space. This one cannot change anymore.
So, Keegan, can I?
Yeah.
Make some statements here. So as we dimension these, we're Keegan's showing all these constraints, but we really want to focus on functional dimensions. So Keegan, so that 0.375 you showed there, I guess I'm going to push back a little, was really what you want there, isn't it? The distance between the two rollers. Isn't that really what you're?
Yeah, that'll be the next thing.
Okay.
This is just because we want this roller to be far enough from the front so that if it gets jostled, that this roller isn't going to hit the front frame.
Okay.
And we also want to make sure that it's not like too far back where it takes so long for our intake to interact with our gears.
Sorry, yeah, I'm sorry.
You're all good. So the next thing we can do is I'm just going to start with one construction line between the 2 points that represent our rollers. And then to get a line that's between that's along the center points and between the two circles, I'm going to put another construction line that coincides with that previous one and that circle. So it'll highlight both of those in orange, like we're seeing right there. And so that creates the first point on that line and that circle. Then I'm going to drag it up to this one until it highlights the line and the other circle in orange. And I'm going to click to confirm it. And then it lets me edit that dimension. What we decided on as a team during the season was that we wanted to compress it only 1/4 of an inch. And these notes are 2 inches around. So that means the distance between these two rollers was 1.75. And we have 2 rollers fully defined.
Could you do that just the last bit again with the lines connected to the circles?
All right. I'm just going to roll back a few steps to show it again. So I'm going to put a construction line between the 2 centers of these circles. Then I'm going to create another construction line that it coincides with that construction line and the 2-inch roller and does the same on the other end. Like that. And then if you don't type it right away, you're able to dimension and it will grab that newest line first. So then we're able to put 1.75. And we have these 2 bottom rollers locked in. The next thing that we want to do is we have to think about the motor that is going to eventually be mounted onto here. So what we're mounting, I'm going to throw the name of it. Not everyone's going to recognize it. We're mounting a Versaplanetary that has a Neo 550 mounted to it. So the main thing we're mounting is that Versaplanetary. So to get the exact measurements for like how big this Versaplanetary is, we can go to, I'm just going to Vex Robotics. I'll actually show all the steps. So we go to Vex Robotics here. We go and we look up Versaplanetary. Then we're able to look at these different products, and what we're mounting is a Versaplanetary gearbox. And we can scroll down here, and it gives us different information about it. What we care about is the drawing. Let me see. Versaplanetary mounting place with pilot. Is this the one? This is the one. So this is what we care about for our distance. We have 2 holes that with a center distance here, 1.949, and that shows that that's going to be true for all plates, but we can also look at the different mounting plates, depending on what we're mounting. But we can use this type all plate for what we're doing. So, for what we're doing, these versaplanetaries they're all in the corners, and it's like a square that's going to be taking up some space on this on this drawing. So we don't, just for the design of this, we didn't want it to be like crooked. We wanted it to be like flat, so the top of it was horizontal and the side of it was vertical. So that meant that our holes had to have a 45-degree angle relative to the floor. So we can start with a construction line. I'm just going to create one out here in space because this is how I would do it. I'm going to create a point by using Shift S, and I'm going to grab the midpoint of it. I'm then going to coincide this midpoint with where we're going to end up mounting this, which is right here. And then what we can do is go back to our document to see how far apart they are. 1.949 is the measurement we want. So we can use the dimension tool, drag out 1.949. And then we want it to be angled, so I'll angle it relative to the center. And that has it at the 45 degrees. And then for a mounting plate, I believe, let me refer back to here. Yeah, we're going to use 1.9 for the measurement of these holes. Or not 1.9, 0.19. And then when we machine this plate, we would use a different drill to actually get out the clearance. Because, yeah?
Sorry, you said angle it relative to the center.
That's a good point. Let me go back. So, to angle it, have this line angled relative to this like floor, or the center is what I called it. What we can do is we use the dimension tool again. We click our line, and then we click this. And since they aren't defined to be parallel, it'll automatically default to an angle instead of a distance. And then when we left click, we're able to input it in amount of degrees. So I just inputted 45 degrees, and that has that line going at 45. I should pause. Is everyone here? Is everyone here? Does anyone need help? Or do we just need time? I'm just going to give a bit of time. What? No. There's a sink in the kitchen.
Just time check, we have 10
Yep.
minutes.
I think. What do we want to do?
Maybe I just make a
We
comment.
can go over resources to do while we're waiting for tomorrow.
Yeah.
I just would like to add a comment that this was actually what Keegan worked through last year to develop the intake for this robot. And it was not just a quick 1 hour process, because we had to iterate a number of times with which gears to use, how far off the ground we didn't know. And by going through and setting up these constraints, then you could change those dimensions as we learned, and it became, or if we discovered we didn't have a certain gear, we didn't have another gear, and we were able to revise the design until it was ready to build.
Yep. During the actual season, it's not going to be like one and done. We make it and it's kind of ready to go. This took like multiple tries. During the process, the 42 tooth gear, the 2.1 diameter, that was originally a 28 tooth gear. I remember that. We lost it. I don't know if we found it yet. But because of the way that we had it defined, we were just able to change the diameter from like 28 over 20. I think we used the gear calculator and put in whatever that value actually is, and we just changed it to 2.1. But that took place over multiple days, and these numbers were just based kind of off of trial and error, because originally that 0.25 is from how far we had it off the ground, but we noticed that on like a concrete poured floor like ours, when we were pushing it around mounted on the robot, that bottom wheel would sometimes interact with the ground and start spinning on its own, just because not all points of the concrete were perfectly flat. So it was kind of like prototyping and just working through. And yeah, that's something we'll have to do all the time. I think right now, if everyone's here, this is a good place enough to stop, and we can pick up from here tomorrow. Just some things. I'd love it if you guys could give me some feedback with this link. The slideshow is also on Slack for those of you not there. I'll keep this up right now. Just fill it out. It says meeting 2. I planned it to go a little slower than it has been, but I think it's good that we're going pretty steadily along. Once everybody has this link, I'm going to switch tabs. I'm also going to go to this. I'm going to create a version of this. So this is going to be labeled as day 1. And so if anyone wants to work from this point, or like you miss some things along the way, you'll be able to go on the timeline here. Oh, this is not in the main document. Yeah. For those on the Swart Dog, you'll be able to go to my student copy Keegan King, and I have a branch called Day 1. I'll try and update it so that this is on the main document as well for tomorrow. All right. Has everyone gotten to that form? Can I switch tabs? All right. So just some resources to look at. One that I've looked at heavily is something called OnShapeForFRC.com. This resource was shared to me while I was at Worlds. They have different blogs showing like different tools that people have made that you're able to use. We'll get into some of these some more. A number of these were used to make the document that you guys are working on. There's this Getting Started tab. So if anyone wants to like look a little bit ahead on like different things that you can do within CAD, or like teach yourself a bit like beyond maybe what we're going to go through in this, you're able to go through this. There's different curriculums here. There's also this library of calculators that is very helpful to use. There's Recalc, A&B Robotics Calculator, Spectrum Design Calculator, all these different things that are helpful to go through during the season. There's also this CAD library. It shows off MKCAD. It also shows off these feature scripts. We're gonna go over how to use feature scripts tomorrow, though, so you don't need to worry too much about this. But these are different tools that just make it easier. Yeah, you can just go through this website. Ryan, what was that other website you had shared with me?
frcdesign.org, I believe, which is some other things, and it has some helpful feature scripts as well as mechanism concepts and
Yeah.
some other things.
This is just another website with some more of the same information. For those of you who really want to get into it and research as much as possible. I actually didn't know about this website until Ryan had shared it with me. There's guides to like the different feature scripts and stuff on here. There's different learning courses, different design handbooks. There's what they found to be the best practices. This is just a good website to go to as well. But I think we can call it there if everyone's happy with that.
Do we want to share the design challenges? Or
I figured that was end of the day or end of the CAD-a-thon.
fair enough. Whatever we want to.
I was planning that for day 4. Anyways, we're gonna call it there. Have a good night, everyone. Let me stop the recording.